Hello everyone, welcome back to my YouTube channel. So in day 20 of Kubernetes series, today we are going to see what is persistent volume and what is persistent volume claim. So this is another volume type which Kubernetes provides us. In previous video we have already discussed about empty dir and host path volume type, but there are some limitations with those volume types and they don't provide us a complete data persistent. So in real time or in production use cases, we generally use persistent volume and persistent volume claim. So let's understand each of them. So persistent volume is a storage resources that provides persistent storage for applications even when pods are deleted or reset used. So basically persistent volumes are separate resources in your Kubernetes clusters. That's why they are completely independent from your containers life cycles. Whatever happen with your containers, they are not worried because they are itself is a separate resources in your Kubernetes clusters. Whenever your application pod needs to access a persistent volume, there will be a request which is raised by your application pod using persistent volume claim, and the application can use persistent volume. You can imagine persistent volume claim as a hard disk. Like whenever we need it, we plug it in our local system, and whenever we don't require it, we will unplug it. So same concept here we have is with persistent volume. This is a cluster level resources, and persistence volume basically are provisioned or can be provisioned using statically and dynamically. So what does it mean by statically provision and dynamically? Statically means your cluster administrator will go and manually create the persistent volume for you, and dynamically provision persistent volume basically automatically created via storage classes. So it can be your local disk like host path, or maybe a remote like your network file share, or maybe if you are using AWS, then you can use EBS volume. If you are using Azure environment, you can use Azure disk. So these are the storage solutions, external storage solution, which you can attach with your application. So they basically provide data persistent. In our demonstration, we are going to use host path because we are using Docker desktop and we cannot integrate any cloud provider storage system. So we will assume host path as a storage device or storage solutions, which we will see in a demonstration. So this is the flow basically. Application pod raise a PVC, then PVC is basically whatever the configuration you have defined in PVC, that should be matched with the available persistent volume. Then your application pod will be bound or mount to your actual storage systems. Now, what is persistent volume claim? So the persistent volume claim is a user request for storage resources. So basically application pod raise a request to use persistent volume. That request is called a persistent volume claim. So it is the essential way for application to request storage from the Kubernetes cluster, specifying the desired size and the access mode like read write once, read write many, and etc. So whenever your application need to use a persistent volume, they will raise a persistent volume claim, which is a request to a persistent volume. So in persistent volume claim, you have to define how much size you needed, what will be the access mode, like how your application pod will access the volume, the persistent volume. So all those things you have to define in persistent volume claim. And once the configuration which you defined in persistent volume claim, Kubernetes basically match that particular configuration with the available persistent volume in your Kubernetes clusters. If that match, it will attach the volume with your application. If it didn't match, then basically you will see the status called like it's in pending state. So here I have defined or mentioned one example here. So you can think of persistent volume is a hotel room and persistent volume claim is a room booking. So the room exists, you have to make a booking to use that room. So similar concept here we have with persistent volume and persistent volume claim. So persistent volume is already available in your cluster. You have to raise a request to use that volume, which you will which basically the request, basically for request you generally use a persistent volume claim, because you are going to define what kind of access you need and how much storage you need. So all those things we specify in a persistent volume claim. Now let's understand few key attributes of persistent volume. So the very first thing is capacity, the size of volume. Access mode, like how your application pod will access it. Reclaim policies, what happened after release. It means like if you want to keep the data or you want to clean it or you want to delete it, so that basically you define using a reclaim policy. Then we have a volume mode, so which means like file system you needed or you need or raw blocks, so like folder or complete blank disk you need. So all those things or all those attributes basically we defined in a persistent volume which we create. Now let's see the access mode. So access mode in Kubernetes define how a persistent volume can be used by a pod. They help decide whether one or many pods can read or write to the volumes. So it again it's depend on the application requirement. So what kind of access mode you need it. So if you are going to use read write ones, in short we call it as RWO. So here basically only single node can read, like your application pod can do a read and write operation on a single node. Basically on one node can read and write to the volume. It is used when you want to access storage for one pod or maybe multiple pod if they are on same node. So it means only single node can do a read and write to the volume. Then we have read only many. So if you want to use like multiple nodes can do read and write operations on your volume. Sorry, my bad. It is read only many. So it means multiple node can do the read operations, but they cannot do write operations. And this is generally we use for if you have a shared config or maybe if you have static content. For that we use read only many access mode. Then third we have read write many. So here basically multiple nodes can do read and write operations on your volume. This is basically best for shared storage like your web servers or maybe your logs. Then we have a reclaim policies. So basically in reclaim policies in Kubernetes define what happened to your persistent volume when the persistent volume claim using it's deleted. So it's just completely with the help of reclaim policies you can decide like if your PVC is going to delete, what you want to do with your data. You want to retain the data, you want to delete the data, or the third one is recycle, which is depreciated, what I have mentioned here. Now let's see how PVC and PV binding process work. So the first users create a PVC. So in simple words, we create a manifest file for persistent volume claim where we define how much storage we need, what kind of access mode we require for our applications, or maybe it's optional like storage class if we are going to use or if we are going to provision a persistent volume dynamically, then we can use storage class as well. Then Kubernetes basically look for the matching persistent volume, like whatever the configuration you have defined in your PVC, that configuration basically Kubernetes use that configuration and match with the existing persistent volume. If the matching, if the whatever the matching or the configuration you have defined in your PVC that match with the available persistent volume, then it will do a mount and the status you will see a bound. If there are no match, then you can see the status of your persistent volume claim in a pending state. So this is the image which I have created. So basically this application pod need to use a persistent volume. So what it will do, it will go and use the persistent volume claim where it define I need 5 GB, I need RWO access mode. So all these things will be defined here. If this configuration will match with the existing persistent volume, then it will bound or it will attach that volume to your application pod. If it will not match, then Kubernetes will try to do a dynamic provision. So it will automatically create a persistent volume based on the configuration which you have defined. But for that you have to use a storage class. And a storage class, like if you have external cloud providers or external storage solutions like your NFS, EBS, Azure disks, for that you can use storage classes. So that's how basically a pod raise a request to use a persistent volume. Now let's see the difference between static versus dynamic provisioning. So in static provisioning, the cluster administrator pre-creates the persistent volume manually, and these persistent volume exist before any PVC requests them. So like before raising a persistent volume claim, which is then raised by your application pod or user, the volume it is already pre-created basically. So whatever the configuration we will specify in PVC, if that match with the available persistent volume which is created by your cluster administrator, then your application pod will be bound to the one of the existing persistent volume. If they did not find the match, then Kubernetes try to use a dynamic provisioning, but for that they need a storage class. So storage class we will cover in separate video. So in this video basically we are going to see in demonstration how we can use a static provisioning, because we cannot do a demonstration on Docker desktop using dynamic provision because we don't have any cloud providers, and we cannot integrate or we cannot add or attach external provider with Docker desktop. So that's why we cannot use a dynamic provisioning, but we will see in a demonstration how we can use static provisioning, where we will manually create the volume and we will use that volume for our application pod using the persistent volume claim. So let's move to a demonstration. Okay, so let me go to my GitHub repo. So here I'll go on day 20 folder. So you can see there are many files which we have here. So the very first is persistent volume.ml. So this is what we are going to create a storage inside a Kubernetes cluster. So if I'll open this file, so you can see the API version is v1, kind is persistent volume, because we are going to create a resource type which is persistent volume, and this is the name of our persistent volume. And under specification we have defined the capacity, like the 1 GB storage we are going to create inside Kubernetes cluster. So the size of persistent volume will be 1 GB, and the access mode we are going to use read write once, and the reclaim policy we are going to use written, because we want to keep our data. And as we cannot use external cloud provider storage system with Docker desktop, so for demonstration I am going to use host path as a backend storage system or a backend storage device, for example. So this is the path which we are going to mount which we are going to mount inside our worker node. and we are going to use here type directory or create. So it will check if this path doesn't exist on worker node, then it will go and create this path. And one more thing, as I'm running this on Windows system, so it is not possible to directly access the worker node. Like we cannot directly SSH to worker node because in background the Kubernetes or the Docker basically use lightweight version, or we can say a small virtual machine where actually our containers run. So to demonstrate this, what we will do, we will first create persistent volume. We will create a persistent volume claim. Then we will create a application pod where basically we will write a file inside this persistent volume. And what we will do, we will delete that pod and we will create again new pod, and on that particular pod we will again mount, or we will use this persistent volume, so we will able to see the file. That's what we are going to see in this demonstration. If you want to see a complete demonstration how we can use persistent volume with cloud providers, for that I have already a video on my YouTube channel. So let me open it. So if you go to AWS Zero to Hero series, there is a video called Day 34. So here I have already explained about EKS, persistent EVS storage and load balancers. So if you want, you can go and watch this video, so you will get more clarity how in real time we can use a persistent volume, where I'm using AWS EVS as a storage system for our Kubernetes cluster. So let's move to our demonstration part. So let me do one thing. Let me first create this file in my Visual Studio Code. So let me copy the name and I will go and create a new file here. Now let me apply this file, kubectl apply -f and file name. Okay, so before that let me copy the content as well. Okay, so now I will apply this file and let's verify kubectl get pv. PV is a persistent volume basically. So you can see this is the name of our persistent volume, which is my local PV. The capacity is 1 gigabyte. Access mode we can see read write once. Reclaim policy we can see retain, and status is available, but we cannot see any claim status here. So now next thing what we will do, we will create a persistent volume claim. So for that I will go to persistent volume claim.ml file. So here if you can see, so this is the request which raised by the user or application. So for example, my application need a 1 gigabyte storage space. So we already have a persistent volume with 1 gigabyte space. If we will request for 2 gigabyte space here, then my persistent volume claim will not be successful because there are no persistent volume available in my cluster which has 2 gigabyte volume size. So the status will be in pending state of this persistent volume claim. So now let me go and create this file as well. And let me copy the content. Okay, now I will apply this file as well, kubectl apply -f and file name. Let's verify kubectl get PVC. So you can see the status is bound. It means it is found the match, because the capacity, access mode, the same we have defined in persistent volume. Read write bonus and storage is 1 gigabyte, and this is the requirement which we have send to this persistent volume, or Kubernetes basically find, okay, the request which is raised by user is matching with the available persistent volume. That's why we can see the status is bound. If we will mention here 2 GB, then the status will be pending. So if we have to verify, let me do one thing. Let me change the file size here 2 GB and let me save this file. So if I will reapply this file, so we are getting error from server. Okay, so you can see the PVC must support resize. So we are getting error because we don't have exact the size, because we have mentioned it 2 GB and we have a persistent volume with 1 GB, so it is not supported itself. So that's what we are getting an error here. So let me change it back to 1 GB and let me check the status kubectl get PVC. So this is the old one which we are getting, my PVC, because this request itself is failed. If you clearly see, the storage is 2 GB and error when patching persistent volume claim IPVC is forwarding, only dynamically provisioning can be used because we don't have any persistent volume with the size of 2 GB. So let me clear this screen and let me reapply it. Okay, so it's unchanged, that's fine. Now next thing what we have to do, let me close this browser. Okay, so now I will go and create my pod. So this is the pod.ml file. So here basically what we are going to do, we are creating, or we are mounting this slash data directory inside the container, and inside this folder we are going to create a file called demo.txt, and this is the volume which we are using, the name which is demo storage, and persistent volume claim, and this is the claim name which we have already created. So let me copy the content and let me create a file pod.ml. Okay, let me save it and let me apply it. kubectl apply -f and file name. So let's verify the pod, kubectl get pods. So the container is creating, it's fine. Okay, so we can see the container status is running. Now what we will do, we will verify the log of this container, kubectl get logs, sorry, not get, kubectl logs and name, which is demo-pv-pod. Okay, so we are not able to see any logs. Let's do one thing, let's describe this pod, kubectl describe pod, sorry, pod and pod name, which is this one. So if I'll go here, let's verify the volume. So you can see the type is persistent volume claim, and this is the claim name. So, and if I'll go to mounting path, so okay, so it is mounted inside, sorry, on slash data. Now what I will do, I will go inside this container and will verify if this file is exist which we have created, and file name should be demo.txt. Now let me clear the screen, kubectl exit-it and pod name, so which is demo v and --sh. So if I'll do ls here and I will go to cd.data directory, I'll do ls. So here we have a file called demo.txt. Now what I will do next, I will delete this pod and I will recreate a new pod, and on that pod we will attach a same volume. So let me exit this container and let me delete this pod, kubectl delete pod, sorry, pod and pod name. Okay, so typo, cubes ctl. So meantime it's deleting. Let me go to my GitHub, and if I'll go to inspect hostpath.ml file, so here what we are going to do, we are creating a new pod, and we are using same busybox image, and we are mounting on this location, right? So if you can see in previous path, previous container, we have used slash data as a mount point, but here we are going to use slash mount slash host directory. So now the demo.txt file should be available inside this directory, because we are going to use, okay, so actually here basically we are going to use the existing directory which is already created in the worker node, because we have defined here type which is directory, we have not defined directory or create. So the same directory we will use for this path. So we already have a demo.txt file on this location. If I will go back to my Visual Studio, so here you can see, uh, so the mount path was slash data, sorry, not here, let me go to my persistent volume, so slash data slash pv demo, and if I go to this file, so the same path we are using here. So it means whatever the data we will have in persistent volume on this particular location, the same data we will able to see inside this container as well. So let me create a file, let me copy the name first. Okay, so let me verify the pod first, kubectl get pods. So we don't have any pods, so let me apply this file. If you can see, on this file we are not going to create any files, we are just using that host path which we have used in our persistent volume claim, sorry, not persistent volume claim, in persistent volume basically. So let me apply this file, kubectl apply -f and a file name, very good, kubectl apply -f and file name which is inspect-hostpath.ml. so this will again create a new pod for us. So let's verify, kubectl get pods. Now we will inspect this pod. So what I will do, I will go inside this pod, kubectl exit -it and pod name and --sh. Okay, so it is still creating, let me rerun it. Okay, let's verify the pod status. So it's in creating state, so let's wait couple of seconds. Okay, okay, let's see in case if is there any issues. kubectl describe pod and pod name. Okay, so we are seeing error here, failed mount. Okay, so it is telling data slash pv demo hyphen is not a directory. Okay, so basically we have missed one thing. here basically we are not going to create the file, because we have already created this in persistent volume. So what we have to do here, we have to change this, because we are going to use existing persistent volume with this inspect host. So what I will do, let me name it PVC hyphen storage, and here I will use persistent volume claim, and claim name was my hyphen PVC. Let me save this file now, and let me clear the screen. kubectl get pods. So let me delete this pod first. kubectl delete pod and pod name. Okay, it is deleted. Now let me reapply this file. kubectl apply hyphen f. Okay, okay, name not found. The pod inspect is invalid. Specification containers volume mount. Okay, so here we have to change the name as well. Let me change it. So I will reapply it. Okay, now let's verify the pod. Okay, its container is creating. Let's wait couple of seconds. So now we can see the container status is running. Now we have not created any file from the under this pod. So we have created a file from this particular pod, which is demo.txt, and we have deleted this pod. Now inspect this pod. So I will go to kubectl exec-it and pod name --sh. So let me go inside this ls, and here we have used a mount path which is /mnt. So I will go, sorry, cd/mnt. Let me do ls. So here we have host cd host, and if I do ls, so now we can see the demo.txt file. So it means the persistent volume claim is working fine with host path, because on this pod we have not created any file. We were using a same file which we created as part of this pod, and we have deleted this pod, which is demo pv-pod. If I'll exit from this pod, and if I clear the screen, if I do kubectl get pods, so we don't have this pod which the name is demo-pv-pod. So it means whatever the data we have inside this directory, which is created as part of this particular pod, same data we are able to see with inspect-hostpath.ml file. So it means the data is persistent, but this is just for the demonstration we have used for host path. What in real time we should not use this, because I just want to showcase how we can use a persistent volume and persistent volume claim. If you want to see in a real time, you can go and watch my Zero to Hero series of AWS, and on day 34 there's a video for AWS EBS persistent, and you can watch and you can get an idea how basically we can use in real time as well. So that's all for today. I hope it's clear. In case if you have any doubts, you can ping me over comments. So see you in next video. Thank you so much.